All right, so you were supposed to put some word meanings behind these numbers, make our numbers make sense. Does anyone have a situation they want to share for the first graph? Yes.
I could be wrong, but I was thinking maybe like for number two.
Number two?
Yeah, I was thinking the 200 would be feet.
Okay.
And the 9 would be seconds.
Okay. So something takes 9 seconds to drop 200 feet?
Yeah.
Yeah. Good example. Yes, ma'am. Yep.
For number one, we said a balloon gets kicked 30 inches in over 8 seconds, or over in 8 seconds.
Okay, so a balloon being kicked for number one. Nice. You said 30 feet in 8 seconds?
Yeah.
Yep, okay. Anything else, either for any of the graphs? Yes.
For four, I put birth fatality rate after invention of
Say that one more time.
birth fatality rate per year after invention of new medicine.
Okay. Birth fatality rate after an invention of a new medicine. Well, that's good because graph 4 is going down. So that is good. Yes. Nice. Okay. Do you want me to share mine? Yeah? Okay. So for the first one, and again, yours are not wrong. Okay. We can all have different things and be right. I looked at number one. I said a plant that was 30 centimeters tall, growing 5 centimeters over 9 days. So something increasing in height. We kind of agreed there. Number two, I used money personally. I said you start with $200 and you spend $25 each month until you don't have any left. And it took you 9 months to lose your $200. Number three, I said a baby born at 12 pounds, gaining 6 pounds every 2 months. That's a little extreme, but maybe it's my baby. Oh. And then for graph 4, I put kind of like yours with the destination. I said reaching a destination in 7 hours. So like the Y being the distance away, and then over time you're getting closer to where you're supposed to be. So that's what I used. Y'all's were awesome. Thank you for talking math. I know it's not the easiest thing in the world to do. Okay, but today our numbers are going to make sense. Okay, we're going to give our numbers meaning today, so not just numbers in general. Okay, so listen, guys. So we're straying away a little bit from the transformation stuff, but we are going to more focus on lines and giving them meaning and how to find. Have you heard of line of best fit? Possibly in the past. You've done it by hand in the past, and today I'm going to show you how to use Desmos to do it for us. Okay? So we're shifting a little bit, but we're still in the same world of linear equations. So remember, there are different ways to write linear equations, okay? And it all really depends on what's given to us, okay? If they give me a slope and a y-intercept, then I can do y equals mx plus b. If I have a slope and I have a point, I can use slope point form, okay? If I only have 2 points, I can use those to find my slope and then put it in point slope form, and then I could even convert that into y-intercept form. You ready? So example 1, okay? So our first 2 examples are very algebra 1 review. So let's just kind of getting us back in that mindset. Number 1, the graph shows the distance asteroid 2019 GC6 travels in x seconds. Write an equation of the line and interpret the slope. Okay, I'm going to stop right there and answer that question. So looking at the graph they gave me, what information is on that graph? I see the point 6 and 21. All right. The time that it took. How many miles? So what could I use to write an equation? But I need something else. I can't just use a point. Do you see slope? You do? What's slope? What is it? I can't see it. You can see it? Is there another point here? There is. It's not labeled. It's starting at 0, 0. If no time has passed, it hasn't traveled yet. So we do have that point 0, 0. So I have 2 points. I also have a point and a y-intercept, don't I? Okay. So all I need to do is use these to now find my slope. Okay. So I'm going to put it into y equals mx plus b. What's nice is I already know that b equals 0. So all I need to do is to find find slope. Okay. Slope is, someone said it, rise over run. Okay. So that's going to see how do my y's change divided by how do my x's change. That little triangle symbol is a delta symbol. It means change. Okay. It's not just a sorority or a frat. Okay. Delta means change in the math world and science world. So how did my y's change? If I went from 0, 0 to 621, how did the y's change? I went up by 21. How did my x's change? From 0 to 6. All right, so what is 21 divided by 6? About 3.5. Okay, so I have the equation, 3.5x. It said I needed to interpret it. So again, give my number meaning. We said it was y over x, right? What are those labeled? Distance over time or miles over seconds. So if I said 3.5 miles over seconds, what does that represent when it comes to the asteroid? So what are you talking about when it comes to the asteroid? It's speed. So this slope is representing the speed of the asteroid. It is traveling 3.5 miles every 1 second. It's kind of fast. We're good with interpreting? That's very algebra 1. Okay, so this is the speed. Now the second part says the asteroid came within 136,000 miles of Earth in April 2019. About how long does it take the asteroid to travel that distance? So if it was that close to us and it would have actually kept going, how long would it have taken it to make impact? Okay. So they gave me 136,000. Is that miles or is that seconds? Miles. Am I going to plug it in for X or for Y? For Y. Y is my miles. Y is my distance. Okay. So 136,000 equals 3.5x. How do we find x? You got this. Divide, and what do you get? I heard it. 38,857 seconds. That converts to about 10.8 hours. Yep. So kind of too close for comfort. Got kind of close, didn't it? Questions on that little algebra 1 review? Using a graph to make an equation and then evaluate. Okay. Our next example, we're going to compare 2 different pieces of information. Okay. So you have a group that wants to rent a venue for prom. Okay. To compare the 2 different venues, okay, we have the Sunview Resort and we have the Lakeside Inn. Okay. The total cost at Sunview Resort is represented by the equation y equals 10x plus 600. Okay. Lakeside gave me a list of points showing how many students are going to come and the total cost of what the prom is going to be. Okay, so 2 different ways of information shown. It wants to know which venue charges a greater rental fee. So they both have a rental fee plus a fee per student. So looking at Sunview, what would it cost for just renting the place? Is it the 10 or the 600? It's the 600. Okay, so here we're looking for y-intercept. Okay, so when your x is 0, when nobody is there yet, what's the cost of just getting the place? Okay, so for Sunview, it's 600. I'll put it over here. Sunview is 600. Okay, we need to find that same information over here for Lakeside. Okay. Does my table start at 0? No, it starts at 100. Okay. So I have a whole bunch of points. Could I find a slope using those points? Yes, I can. Change in y divided by change in x. How is the cost changing each time we increase? We are adding 300 each time we add how many students? Each time we add 25 students. So if I do 300 divided by 25, what is the cost per student? 12. Okay, this is my slope though. This is not my venue. That would be nice if it cost $12, but it doesn't. So it costs $12 per student to be at the venue. Okay. Well, it asked me how much the venue is. So let's use point slope form. I have a whole bunch of points. I have a slope now. Which point would you like to use? Which one? 125, 1800? Cool. You have 5 options. They all work. They will all give you the same result. So if you're like, oh, I really wanted to use 100 and 1500, use it. We're going to end up with the same thing. Okay. So from the box above, we're using this one. Okay. Y minus y1, which we're going to use 1800, equals my slope times x minus x1. We're going to distribute and simplify this equation. So this gives me y minus 1800 equals 12x, and it's Friday, so my brain isn't working, minus 1500. I'm going to add my 1800 over. We get y equals 12x plus 300. So this is for Lakeside. So how much does it cost to rent the Lakeside Inn? $300. So it's cheaper to rent Lakeside, but the cost per student is cheaper over at Sunview. Does that make sense? How we can compare these two together? All right, so but it wanted to know rental fee. So Sunview has a greater rental fee. Word problems get word answers, right? There we go. The next part of this wants to know how many students have to show up to prom for our costs to be the same, regardless of which venue we pick. Okay, so I have 2 venues. I have 2 equations. How do I know how to make them when they're going to be the same? Make them equal to each other. Okay, so we had 10x plus 600 equal to 12x plus 300. Now what? And then subtract that 10 also. And then divide. So how many kids? 150. So if 150 students are attending prom, it doesn't matter where they go. It's going to cost the same. Ooh, what would it cost? Bonus question. 2,100. Good. Okay. Are we ready to step into Algebra 2? Are we in the world of modeling linear functions? Making our numbers make sense. Okay. So on the back, we are going to find lines of fit because this was nice information on the front. They were nice and perfect and consistent, but life is not always perfect and consistent, is it? Okay. Data do not always show exact linear relationships. When the data in a scatter plot shows an approximately linear relationship, you can model that data with a line of fit. Okay. So this is not line of best fit. This is just a line of fit. Okay. We are going to make a scatter plot. We're going to draw a line through those points, trying to have the same amount above versus below my line. We're going to choose 2 points on that line to find slope and create an equation. Okay. So do we see how this isn't line of best fit? It's just line of fit. We're doing a whole lot of guessing here. Okay. A whole lot of approximations and generalizations. Okay. You can't include all the data, really, which is why it's not the best. So let's use it with example 3. So we're going to do our general line of fit, and then we're going to find the line of best fit and see how close we got. Okay. The table shows the femur lengths in centimeters, that's in your leg, and heights in centimeters of several people. Do the data show a linear relationship? So do you think the taller your femur is, the taller you are as a person? You think as that grows, as your leg grows, your height grows? Does that logically, does that make sense? Okay, let's see if the data shows that. So in our head, we're like, yeah, that should totally be a thing. Well, let's make sure. Okay, we have data. We're going to make a scatter plot. Okay, please don't stress. Do your best. All right, we have 40 and 170. These lovelies are going up by 20s, so if you want to label those in between, you can. Our X's are going by 10s. All right, so we have 40 and 170. 45, 183. 32, 151. See how I'm just making my best guess, friends? Yes? Okay. 50 and 195. 37 and 162. 41, 174. About right there. 34, 151. 47, 185. 45, 182. It's not beautiful, and it's okay. It doesn't have to be. Okay. All right, so from here, my next step is, it says, does the data show a linear relationship? Does that kind of form a line? Are they gradually increasing? Yeah, I would say yes. Okay, so the math is making sense. So now we're going to write an equation of line of fit, and to use that to estimate the height of a person whose femur is 35 centimeters long. Okay. So step 2 told me to draw a line through my data, trying to fit the same amount above and below my line. So I'm going to go like that. Is that okay? Okay. Some above, some below. Then it told me to pick 2 points on my line to create the equation on my line. Okay. So I like this guy. Do you like this guy? That one was nice. What is that? 50, 195? What else looks pretty nice? 40 and 170? That one? That works. We can do that one. All right, so to write the equation of a line, let's find a slope between those two. So again, slope is change in y over change in x. So how did 170 become 195? I went up 25. Good. How did 40 become 50? I went up 10. So that's about 2.5. So we'll use that for my slope. Now I have a slope and I have 2 points. Let's use them to do point slope form again. Okay, which one do you want to use? The 40, 170 or the 50, 195? Okay. So y minus y1 equals my slope times x minus x1, like that. I'm going to distribute that through to give me 2.5x, and then that gives me minus 100. I'm going to add the 170 over. We have the equation y equals 2.5x plus 70. Okay, so here's the equation of our line. Of the line of fit that we kind of drew. All right, it's supposed to be to use this to estimate the height of a person who is 35 centimeters long. Their femur is. So where am I going to put 35? The X or the Y? The X. Good, that's my femur length. So plug in 35. So 2.5 times 35 plus 70. We should get about 157.5 centimeters. That's about 5'4", by the way.
Where do we get the 35?
I know it's not 5'2". It told me. Right here, estimate 35. So that's where it came from. Good question. So if someone's femur is 35 centimeters, they're about 5 feet 2 inches, not 5'4". They're about 5'2". Oh, if you can please wait, that would be fantastic. If you can't wait, then yes. From our slope. So we chose the points 40, 170 and 50, 195. So I found the difference between those 2 points specifically. Yeah. Okay, so going back to that, we have more than 2 pieces of information, right? They gave me how many people here? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 10 people. We really only use 2 people to do this, correct? We only pick 2 out of the 10. So that's why it's not a line of best fit. A line of best fit would use all of my data. So that's what I would like to use if it's possible. It's okay, and it is. Okay, so define our line of best fit. We are going to use our calculators. Okay, if you have a handheld, there are typed instructions down here on how to use them. Okay, but since Desmos has become a thing, okay, we have figured out how to use Desmos. I promise you're going to like it better. Okay. Is anyone having to use the handheld today, or do we all have our Chromebooks? Wonderful. Okay, well, let's do Desmos. So we are going to use the exact same data. We're going to let Desmos give me the equation of a line. Then we're going to use that equation to plug in 35 and compare our answers to each other. Okay. So have we all opened up Desmos? We're here. Okay. You probably don't have that yet. Yours looks like this. Yep. We're here. Okay, there's a plus sign. Push the plus sign. You're going to add a table. So plus table. Okay, it's created an XY table for us. We are going to type in our information. Okay, type in our information. So all of my X's for my femurs, it was 40, 45, 32, yep, 50, 37, 41, 30, 34, 47, 45. And then you're going to type in your Y values. 170, 183, 151, 195, 162, 174, 141, 151, 185, 182. So whether you're doing handheld or Desmos, make sure your lists line up. Because if they're not the same amount, we are missing something. Make sure they are the same. Come back. Thank you. All right, we good? Is our data in? Now, did any of the points show up? No. You don't have to see them, but would you like to see them? Yes? See the magnifying glass down here? Click that. And it'll adjust your window to make your points show up. On your handhelds, there's a whole lot you would have to do to make that happen. Okay? But again, we don't have to see it, but it's nice to see it. Do those kind of form a line, though? We can see the trend. Yes? So remember our scatter plot? This is my scatter plot. So we can see almost better through here. You can do scatter plots now through Desmos to see the trend. Okay. Now, my line of best fit. Scroll up if you have to on your table. At the top next to X1, Y1, you should see a little line with some dots on it. Click it. Does anybody not have that feature? Okay. So look, linear regression. It's given me the equation 2.6x plus, we'll call it 65. Yeah. In the future, we're going to use this for a quadratic. We can find a cubic. It's trying to match it with the points that are there the best that it can. Okay. We're actually going to use all of those at some point. Right now, we're just doing the line. Okay. So our equation is y equals 2.6x 2.6x plus, it was 65, right? So how does that compare to what we said? We said it was 2.5, so pretty close. And we had plus 70 when it should really be plus 65. So we were close, but it's not the same. Okay? This is best. Now plug in 35 and see how close we were to that. Plug in 35. See how close we were to the 157.5 answer. Oh. What do we get? 156? Anybody else? I like to get like a 2 or 3 people. We agree? Anybody else agree? I see some nods. Okay. So about 156 centimeters. So we were close, right? But we were 1.5 centimeters too high. The line of best fit tells me about 156 centimeters. Okay. So Is the line of fit awful? No, but you don't get to use all of your data. Line of best fit uses all of the data you've put in to create the equation. What's up? Because it told me. Because we plugged in 35 up here. It wants us to do it again with our new equation and compare our answers. How do you compare? I'm comparing 156 to 157.5. So we were close, right? But our line of fit was technically too much in my answer.
How did you get that equation? I'm sorry, I'm behind.
All right, so if you were using a handheld, I think I saw, did you use the handheld? And you got the same thing, right? Yep. Okay. If you ever need to use it, that's what these steps are for. These are for steps on how to use the TI-80 force. Okay. I would like you to use technology for the humerus. Okay. So don't do it by hand. I'm gonna do it by hand. You're gonna do it by calculator, and we're gonna see how close we are to each other. Okay. So you have a new set of data. So I would X out of your table and bring in a new one. So go to Desmos at the top here. X out of that table, bring in a new one for your data. So let's compare with what I did versus what you did. I just did a line of fit. Okay. Scatter plot showed a linear trend. I picked 2 points. I picked 22, 130 and 27, 145 to find the slope of 3. And then to make an equation, I got y equals 3x plus 64. What was your equation? Y equals, okay, 3.1x plus 64. Okay, so we were pretty close, right? It was pretty close. It wasn't the same, but it was very, very close to it. And then what did you get when you plugged in a female whose humerus is 40 centimeters long? What did you get out of that? When you plugged it into this, though, 3.1 times 40 plus 64. I also got 188. Okay. So we were way closer this time, right? So our data was way closer. My y-intercepts were the same. My slope was barely off. But even just being 0.1 off in my slope, did that affect our final answer? It affected it by what, 4 centimeters? Okay. So does it matter? Yes, it does. Okay. Any questions for me on this? No?